Did you want to do more math? Did you want to see more math problems? You came to the right place. So let's look at the homework assignment. Let's start with looking at number 7. A group of diners were asked how much they would pay for a meal. And these were their responses. We're going to use GeoGebra to analyze these responses. Then we're going to go over here. I want a little bit more room here. I'm going to slide this over. We don't need this stuff from earlier. Copy and paste. This time, I'm just going to select the whole row since it pasted the data values horizontally. One variable analysis. Nothing happened. So you'll see this every once in a while, okay? If you see that, then just write them down manually. $7.50, $8.25, $9, $8, $7.25, $7.50, $8, and $7. All right, and we'll get rid of this copy pasted data. It's just a weird little bug. So now we're going to make one variable analysis with this new data. It should create our histogram, and we are just going to go over to show statistics and look at this information. So when it says find the mean, we're going to say the mean is $7.81. And we'll write that down, $7.81. These units are important, and we're going to include them. We're going to round like this too, right? Because we're going to round to the dollars and cents. The median is the middle value. You could reorganize these, size them, smallest to largest, or you can use GeoGebra, and GeoGebra says the median is $7.75. Again, units are going to be important here as well. 5-number summary, minimum, Q1, median, Q3, and maximum. That's 7.375. The median, we already got that. That's 7.75. Q3, 8.125. And the maximum, which was 9. This incorporates all this important information that we needed. I didn't include this in the videos, but you can also have GeoGebra make a box plot. They don't do small vertical bars for the minimum, the maximum. They do big vertical bars. Everyone does it a little different. But it still shows the 5-number summary. Minimum, Q1, Q2, or the median, Q3, and the maximum. And that's problem number 7. We're going to look at the histogram from number 3 and talk about some information here. Histogram from number 3. And then we're going to start by talking about the median. Wait, that's a bar chart. It's a bar chart, not a histogram. So we're going to look at this information, and I don't want to scroll up and down. I'm going to write down this information. It's easy for me to copy. We don't need to copy it. This is essentially a frequency table, right? Bar chart shows a frequency table exactly. So there are 5 zeros. If you'd like to, you could write down the data like this. There are 5 zeros. 1, 2, 3, 4, 5. There are 3 ones, right? Under 1, the frequency is 3. There are 3 ones. We're going to write that down. 1, 2, 3. There are 4 twos. 1, 2, 3, 4 twos. There are 2 threes. 1, 2 threes. There are no 4s. We don't have to write that down. And there's 1 5. We can write down 1 5 like so. And hopefully, if we click on one variable analysis, and then we look at a bar chart, this should match exactly this. It's the same bar chart, same data. So if we're using GeoGebra, and again, I talked about other ways of solving this as well. You could do it in different ways. The mean is going to be 1.4667. 1.46 repeating. All right, so 1.46 repeating, 1.47 children. Again, the mean has the units of the data. The average person has 1.47 children, which is why average doesn't really make sense in some cases as well. The median number of children, though, is 1. The typical person, in this case, and even then it's a little misleading, has 1 child, because it's actually not that common. There's much more common to have 0 or 2. But anyway, 1 child is going to be the median. 5-number summary, minimum Q1, median Q3, Q5. Whoop, Q5, that doesn't exist. Maximum 0, 0, 1, 2, 5. That's our 5-number summary. And create a box plot. Done. This box plot looks a little weird because the minimum is actually the same as the first quartile. So that little vertical bar that we usually draw is right here. If you want to put this on your homework, a couple of ways of doing it. The easiest is to go over here and just export as picture. You click on this, it will download a file. And you can insert that file into your homework. Or you can just copy this down. Here's the values on the bottom, and you just copy this down on your own paper. It's up to you. All right, next, let's do problem number 12. Let's look at this box plot. 2 box plots. What percentage of actuaries make more than the median salary of a CPA? So actuary stuff is down here. CPA is up here. They're kind of similar. Actuaries make a little bit more, but then the distribution is quite different, right? The median for an actuary is much higher, relatively speaking, than the median for a CPA. So what percentage of actuaries make more than the median salary of a CPA? So the median salary of a CPA is right here. That's about $75,000 a year. So how many actuaries make more than this? Well, the median for the CPA is the 25th percentile, the first quartile, for an actuary. So what is how many actuaries is this? 75%. I should have typed that, not drawn it. But the median right here is 75. How many actuaries make more than 75K a year? 75% of them, because this is the first quartile for actuaries. All right. There's a very big difference between the minimum and the first quartile, which is kind of interesting. And that's how you do something like this. Lastly, let's look at number 16. This is a bit of a weird one. So there's a sample, and that sample has 30 distance scores. So there are 30 data values. They're all distances. We don't know what the distances are. And they're all measured in yards. So we have 30 data values, all measured in yards. We know their mean. The mean is 7 yards. Variance is 16 yards squared. And standard deviation is 4 yards. So on average, these distance scores are 7 yards, plus or minus 4 yards. We want to convert all these distances from yards to feet. So all of the data values, right? If there's a data value of 7 yards, it's now 21 feet. Because 7 yards is 21 feet. We don't know the data values here, but we're multiplying every data value by 3. Question is, what happens in the mean? We don't know anything about the median here. It didn't mention the median. What happens to the new mean, the variance, and the standard deviation? And so you look at the formulas to find this out. What is the mean? The mean is adding up all the data values. If the data values are all getting multiplied by 3, then if we add them up, we can factor out a 3, and they'll also all be multiplied by 3. Okay, and there's a cool little mathematical proof for why that happens, but we're not going to talk about it here. The mean is multiplied by 3. What about the variance? Well, let's look at the variance. Variance is s squared or sigma squared. And that is a little complicated. But we're squaring everything. Okay? The mean is multiplied by 3. The data values are multiplied by 3. So this whole thing is multiplied by 3. And we square it, it gets multiplied by 9. So Again, there's a complicated way for where this comes from. You don't have to worry about it too much. The variance is multiplied by 9. Again, the variance is just the standard deviation squared. And by the same logic as before, standard deviation is multiplied by 3. We can say the mean and the standard deviation are multiplied by 3. This problem is actually kind of a fun problem. It's a little bit outside the scope of this class, but here it is. So what if we subtract 4 feet from each of these data values? We're moving all of our data 4 to the left, subtracting 4 to all of these. What happens to these things? Well, if we subtract 3 from everything, you can kind of do a couple examples on your own and see what happens. But the answer is going to be that, well, if all the data values are subtracted by 4, then again, you can kind of do a little factoring trick. And the mean is 4 feet less. But the variance and the standard deviation are the same. That's kind of interesting. Because remember, the mean talks about where the center is, but the variance and the standard deviation are just how far you are from the mean. But if we're moving everything, then the spread doesn't change. Variance and standard deviation have to do with spread. Right? If I added values to all of these numbers, the spread is still the same. You know? And that, maybe you don't know, and that's why you're watching this video. But that's kind of what's going on. And you can try it. Like, look at a data set. Let's look at this data set from an earlier problem. If we just add 4 to each of the, let's add 3 children to each of these. Then the question is, like, what happens to the standard deviation? And my claim is that the standard deviation in both of these are the same, even if we're adding 3 kids to every household. Goodness. So the first one has a standard deviation of 1.46. The second one has a standard deviation of 1.46. Okay, and the variance is actually the same. Okay, because the variance is just the standard deviation squared. So if the standard deviation is the same, the variance is unchanged as well. Kind of a cool little problem. A little outside the scope of this class, but fun to talk about. So here we are. Let me know if you have further questions about these homework problems and we can talk about it.